This is just a quick video to help with taking vectors and breaking them into components. So you can see here I've got two examples of vectors. Let's look at the first one and start to break it apart. So it's on an angle. That means I have some of it which is going to be in the x direction and some of it which is actually in the y direction. We've talked about how we can use a parallelogram for two vectors to add. In this case, they're at right angles, so I have a rectangle. Now, if I want to know how much of that vector is in the x direction, then that means I'm interested in the length of this line right here. So we're going to have to use some trigonometry. Oh, come on, it's not that bad. So let's think back to math class. This black original vector then is going to be the hypotenuse. It's obviously the longest side. Let me write that in. And if I've got that angle of 28, that means the one I'm interested in, this one here at the bottom, that must be the adjacent side because it's right beside the angle we're talking about. So right now I've got the adjacent side and the hypotenuse. So let's think back to our math class. Either you might know SOHCAHTOA or Sophia catches toads. Either way, the one that's adjacent at hypotenuse is cos. So this could be written as cos 28 is going to be adjacent over hypotenuse because cos is always adjacent over hypotenuse. If I fill in the numbers that I know, cos 28, I don't know the adjacent side, that's the one I'm looking for. Or actually, let's get rid of that. Let's go back and let's put an x there because it's in the x direction. And the hypotenuse we see there is 15 degrees. So if I want to get x by itself, it's going to be multiply both sides by 15. 15 cos 28. Now if I pick up my calculator, making sure it's in degrees, 15 cos 28 is 13.2 dot 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 dot. Let's round it to three significant figures. Okay, so that's the x direction. Now let's calculate the y direction as well. So that's going to be this arrow right here. And that would be the same as this side. Okay, so that is opposite my 28. So I now have opposite and I do know the hypotenuse. Now I'm going to go back to using hypotenuse and not the adjacent that I calculated. The reason I'm going to do that is just in case I made a mistake, I don't want to make another one on top of that. So now I've got sine because I'm going to use opposite over hypotenuse. So sine 28 is going to be that opposite over hypotenuse. If I put in the values I know, sine 28 is going to be the opposite. We're going to call it y because it's in the y direction, and 15. Moving that around and putting it in my calculator, 15 times sine 28 is 7.042, blah, 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 blah. Let's round it to three significant figures. Or actually, let's do one decimal place since that's what my x value has. Okay, let me do this one more time. I'm looking at my vector b. I want to break it into its components. So it's going to have a x component and a y component. Now they've shown me the angle compared to the y-axis now, not the x. And you know what? We could just figure that out. Hey, that's 90 degrees, so this is a 60 right here. Or we can walk through it the same way we did the last time. I know that the arrow, the original vector, that's, if we added the two together, we'd call it the resultant, but right now it is the original vector. It's going to be my hypotenuse. And beside my angle of 30, this would be the adjacent. So my y now is my adjacent, only because the angle is given to me differently. My x value down here at the bottom, remember that would be the same as if I put it up here. And that would be opposite my 30 degrees. So if I want to know, let's do the y one first. Adjacent and hypotenuse, that would be cos. So cos 30 degrees, adjacent over hypotenuse. Put in the values I know. Don't know what the adjacent is, but I know the hypotenuse in this case is 20. So let's move that around, and let's, instead of writing adjacent, let's put a y there. So y will be 20 cos 30, and with my handy dandy calculator, I know that 20 cos 30, making sure it's in degrees, 17.3. In this case, for the x value, I've already labeled that as opposite. So that would be opposite and hypotenuse is sine. So sine 30 would be opposite over hypotenuse. Put in the values I know. Sine 30 degrees. Opposite, we're going to call that x. Hypotenuse is 20. So x would be 20 sine 30, which is 10. Okay, so now I've got all of my values for this in the x direction and the y direction. And let's see how that's going to be added together. Okay, all I've done is clean up my calculations a little. So we have A, and if I break it into components in the x direction, 13.2, and in the y, 7.0. Stop. Does this make sense? Is my hypotenuse still the longest side? Yeah. And 28 degrees, that's not a very high angle. So that means that I really should have a longer run than I should rise. Yep, looks about right. Same thing with our vector B. Now, if I'm going to add them together, we talked about in class about going tip to tail. So here's my first one. Here's my vector A. There's my tip to tail, and then vector B. And now the resultant is going to be from here all the way over to this part. Now what we don't want to have to do is scale diagrams. It's messy, uses protractors and rulers, and there's so much error. But if you take a look, both of these vectors have a push to the right. So there's a little bit from A and a little bit from B. So the total in the x direction is going to be 13.2 plus 10. And in the y direction, we're going to have 24.3 because they are both in the same direction. Now these are vectors, and if they were going in the opposite direction, then I would subtract them with paying attention to which one's larger, and if I have the top of my page being positive and the bottom being negative, that will tell me what the resultant should be. Now that I've put those two things together, I know that I have 23.2 in the x direction, 24.3 in the y direction. So if I want the resultant and bring those back together, so I have the individual components and I want to get the resultant, that would be my vector addition, and it will be the diagonal of this rectangle or parallelogram if they weren't 90 degrees to each other. So how do I do that? Pythagoras Theorem. So r squared equals 23.2 squared plus 24.3 squared. Solve on the right, take the square root, and I get that my r must be 33.6. Not quite done because this is a vector, and I need this angle right here. Now remember, this is going to be compared to my angle. I've got my hypotenuse. I have my adjacent. I do have my opposite because remember this side is the same length as this side. So I can choose any one of my trigonometry ratios to calculate that theta. So I've decided to use tan, opposite over adjacent. So my opposite value, remember, compared to my theta, it would be right here, same as 24.3, divided by my adjacent. When I put it in my calculator, and remember, I need to separate this tan and theta, so I have to use my tan inverse or to untan both sides. Don't tell your math teacher I said that. And I put it in my calculator and I get 46.3 degrees. And if we look at the diagram that I roughly drew out, that does look about right. So it does seem reasonable. Don't forget when you're doing this, take a little bit of time to do that, especially if you're unsure of yourself, so you can do some estimation to see if you got the right answer.